Did you ever think about how the sun hits the ground? Generally, how does the sun work? Firstly, I want to ask you a question. What would happen if you could pour water on the sun? You have 10 seconds to answer. If it's hard to find out, don't worry, stop the video and try to answer it and write in a comment. I'll check all comments, don't worry. If we could pour water on the sun, a massive explosion would occur. The hydrogen in the water would combine with the sun's already existing hydrogen fuel, intensifying the fusion reactions. This will cause the sun to become temporarily brighter and hotter. Given the enormous amount of water, it could trigger a colossal energy release on the sun's surface. So contrary to what is thought, the sun is not a fire, it's an energy. But how does it produce this endless energy? So, as we said, the sun produces energy, and the name of this process is nuclear fusion. Generally, this is one of the most important processes in the universe. So, the sun is the most critical energy source for life on Earth, and its energy comes from the transformation of hydrogen into helium. But how does this happen? Actually, this process is far more complex than simply two hydrogens make one helium. First, let's learn about both hydrogen and helium. Hydrogen is the first element on the periodic table, symbolized by H, and has an atomic number of 1. It's the lightest and the most abundant chemical element in the universe, making up roughly 75% of its elemental mass. In its natural state, hydrogen is a colorless, odorless, and a tasteless gas. Actually, the number of protons determines an elemental identity and its place on the periodic table. And this means it has only one proton. And the helium is the second element on the periodic table, symbolized by He, and has an atomic number of 2. It's a noble gas and is the second lightest and the second most abundant element in the universe after hydrogen. Helium is colorless, odorless, tasteless, and non-toxic. It's inert, meaning it doesn't easily react with other elements or compounds. Helium is produced in stars through nuclear fusion and is commonly found on Earth in natural gas deposits. Helium has 2 protons in its nucleus, which defines it as helium and gives it an atomic number of 2. Most helium atoms also have 2 neutrons, resulting in a mass number of 4. This is the most common isotope of helium, called helium-4. However, there is a rare isotope, helium-3, which has only 1 neutron. What is this helium-3? What is this helium-4? First of all, when the sun was formed, approximately 71% of its mass consists of hydrogen, 27% of helium, and the remaining 2% of heavier elements such as carbon, oxygen, iron, and etc. These numbers describe the sun's initial chemical composition and they align with the theory of stellar formation. When the sun was formed, it started with roughly 10 to the power of 57 hydrogen atoms. More precisely, the sun's total mass is approximately 2 times 10 to the power of 30 kilograms, and the mass of a single hydrogen atom is about 1.67 times 10 to the power of negative 27 kilograms. Based on this, calculations indicate that the sun started with approximately 10 to the power of 57 hydrogen atoms. So in the sun, 4 hydrogen atoms combine to form 1 helium atom. Every second in the sun, 600 million tons of hydrogen are turned into 596 million tons helium. 600 minus 596. Wait, what? What about 4 million tons? This is another question for you. Stop the video and try to answer it. Because during this process, some mass is lost and converted into energy. This energy is what makes the sun shine and give off heat. So the remaining 4 million tons are turned into energy, which powers the sun's light and heat. Think of like this. You are driving a car, you fill the tank with a 100 liter of fuel, but 1 liter of that fuel disappears as energy. This energy powers the car. You might remember Albert Einstein's equation, E equals mc squared. Albert Einstein's equation E equals mc squared is one of the most famous equations in physics and describes the relationship between energy, mass, and the speed of light. Let me explain it with more details. E represents the total energy of object or a system. It's measured in joules in the International System of Units. M is the raised mass of the object or particle measured in kilograms. It's the intrinsic mass of the object when it's not moving relative to the observer. And the C in a vacuum is approximately 3 times 10 to the power of 8 meters per second. This is the constant and one of the most fundamental quantities in physics. The equation tells us that a small amount of mass can be converted into a tremendous amount of energy because the speed of light squared is such a large number. And what does it mean? In fact, this equation shows that mass and energy are interchangeable. A given amount of mass can be converted into energy and vice versa. This principle is the foundation of nuclear energy and explains how processes like nuclear fission and fission release vast amounts of energy. So in the sun, hydrogen nuclei, protons, fuse to form helium nuclei in a process called nuclear fission. During this process, 4 hydrogen nuclei combines to form 1 helium nucleus. The mass of the helium nucleus is slightly less than the total mass of the 4 hydrogen nuclei. And this missing mass is converted into energy using E equals mc squared. For example, suppose 4 grams of hydrogen undergo fusion to produce 3.97 grams of helium. And the missing 0.03 grams is converted into energy. N is equal to 0.03 times 10 to the power of the negative 3 kilograms. Using the equation E equals mc squared, E equals 0.03 times 10 to the power of negative 3 times 3 times 10 to the power of 8 squared. And the E equals 2.7 times 10 to the power of 12 joules. This is an enormous amount of energy for a very small amount of mass. Imagine you have a small matchstick. When you strike it, it burns and produces light and heat. Now imagine converting the entire mass of matchstick directly into energy. Using E equals mc squared, the amount of the energy released would be billions of times greater than the energy from simply burning it. This enormous energy potential is why Albert Einstein's equation is so powerful and fundamental in understanding both the microscopic world of atoms and the vast energy-filled universe. So, how does hydrogen turn into helium in the sun? This happens through a process called a proton-proton chain, which consists of 3 main steps. Step 1. 2 hydrogen nuclei combine to form deuterium. During this process, 1 proton turns into a neutron, releasing a positron and a neutrino. Step 2. Deuterium collides with another proton to form helium-3, which has 2 protons and 1 neutron. Step 3. 2 helium-3 nuclei fuse to create helium-4, releasing 2 excess protons. And by the way, helium-4 has 2 protons and 2 neutrons. And in this way, 4 hydrogen nuclei combine to form 1 helium-4 nucleus. However, the mass of the helium produced is slightly less than the original hydrogen. And this missing mass is converted into energy. So, what about the sun's life and its importance? The sun is gonna die? What will happen after all the hydrogen is used up? And when will all the hydrogen run out? In fact, the sun is currently in the middle of its life and is about 4.6 billion years old. it will continue to produce energy in this way for about 10 billion years in total. So assuming that you were born today, that you are reborn as soon as you die, and that the average human lifespan is 70 years, you will have to live 77,142,857 times to see the death of the sun. I know, it's crazy. So don't worry, enjoy the life. These nuclear reactions not only fuel stars, but also create heavier elements in the universe. All matter on Earth was once formed in such stellar processes.